Welcome to the Friday Conversations. We're here with Brian McCann, who is the CEO of Intergalactic. How are you?
Doing well, thank you very much.
Thank you for braving the snow. It is snowing quite a bit. It is mid-March, late March, and it's snowing like a fiend.
Right, yeah, coming up from St. George, so when I mentioned the snow, that's the issue for me, is I don't know how to drive in it. So I did go to BYU, but that's the last time I drove in snow. So it's been a bit tough this morning.
Yep. I'm excited for this one because we're going to be talking about awesome stuff. And this is awesome stuff in St. George, Utah. We'll get to that point as well. Tell us, what is Intergalactic, and if you want to go into kind of the founding story or how you've become the CEO, feel free.
Yeah, so happy to talk about it and happy to answer questions later on as well. But Intergalactic is a next-generation thermal management company serving aviation and space, so those markets. Space is the more exciting market everyone seems to be paying attention to. However, aviation also has some pretty exciting things happening with supersonics, hypersonics, electrification with eVTOLs, stuff like that. So the company was founded because the founders, so I'm actually somebody who came in early on as an investor and then actually took over a company called Airborne ECS and transitioned it into Intergalactic. But Airborne ECS was started in 2016, and it was to serve this next-gen market and all these new platforms coming out. And so in aviation, you have this, the way that they've sort of mitigated risk. If you go back to like the 40s and 50s, planes were falling out of the sky all the time. That doesn't happen anymore, and everybody's pretty grateful for that. One of the ways they've done that is they haven't changed much. So some of the same systems they developed in the 50s and 60s we're still using today, which doesn't make you feel very good when you realize that everything else has changed. Everything else is getting digitized and changing, and all that digitization comes with heat factor. So everything's increasing heat. It's like a computer. The more electronics you jam into a small space, the more you have work, the more work you have taking place there, the more heat you're going to generate. And the legacy systems couldn't handle that heat. So the US government realized this and started saying, hey, like, step it up. Like, we can't compete. Everything's changing. We need help here. We need help in thermal. It became the #1 issue in aerospace. So a lot of foresight and these guys getting together, these engineers, and starting to kick this around. In 2018, my company, Ram, invested $2 million in the company, and I led that investment round. So I was working with Ram at that time as the Vice President of Business Development. Ram's a 50-year-old aerospace company in St. George. The company was in Port Angeles, Washington, which was a bit of a challenge. That's almost by Canada, if you know where that's at. But we did invest, and then we ended up doing an acquisition of the company. We brought it down to St. George. The board asked me to serve as CEO in 2019, and so since that time, that's what I've been doing. So that's a little bit of the high-level background.
Yeah, and there's probably going to be a lot of folks that wish they paid attention in physics and chemistry class if they want to understand like the real like nuts and bolts of Intergalactic. But thermal, heat, redistribution, making things work better. What are some of your products and how are they applied?
Yeah, so we're doing fully integrated systems. So there are companies that do thermal materials and stuff like that. What we're doing is we're taking all those inventions and innovations and we're combining them into a system that actually actively manages heat. So these are systems that push coolant. There's also passively managed systems that actually act like radiators. I won't get too technical on that, but these are complex systems. And so that's really what we're designing and building. To give you an example, right now we're just going into production on our first production system. This system is going to be produced at a rate of about 200 to 300 systems a year for the next 15 to 20 years. The system, when it was put into the RFP phase by a government prime, so the defense primes, you guys all know who they are, the big aerospace companies in the US, they got back only one response from a company that responded saying, hey, we could do that system, it'd be 18 inches in diameter and 250 pounds. We learned about it. We actually proactively submitted a bid for 120 pounds and 11 inches in diameter. So saving 130 pounds on platform. The prime called us, thought it was a mistake, thought we didn't understand. We said, no, we can do that, and we have produced it. So that's the market that we're serving, that really lightweight, high-performance thermal management segment.
And in this particular case, is this in defense, aerospace, space? Where's this example?
Good question. So we really play in defense, aerospace, and space because it is a highly optimized system. I mean, our systems cost a customer between $500,000 and maybe $1 million or more. And so these aren't really systems that a commercial operator would want. Somebody said to me, why don't you take this to Tesla? It seems like they could really use this because electric vehicles and thermal. Tesla doesn't want to put a $500,000 system in a Tesla. So it's, anyway.
Yeah, not yet at least.
At least not yet, yeah.
So the biggest problem that you're solving is when Chuck Yeager was flying P-51s, not a lot of electronics, right?
None, yeah.
And now, somebody flying an F-35, it's like a supercomputer. It needs to work for a lot of reasons. And with all of that heat, without systems and engineerings and polymers and compounds, it wouldn't work and it would fall out of the sky.
Right.
So this involves, in my feeble brain, like a typical startup would have engineers, product, all of that. But you guys probably have Skunkworks and laboratories and research and development. I'm interested in that because you guys actually make something. How does that work from the idea in somebody's brain to the testing to the building to selling it in big numbers?
It's actually a differentiator for Intergalactic. We are a different aerospace company. If you guys follow us on social, if you interact with us at all, you're going to see that right away. But most aerospace companies in the supply chain, they don't understand the power that they have, and so they're very reactive. And what I mean by that is they get a specification. It's a design specification. It comes with all the parameters for the functionality for the system. And then they quote it, and then they try to make it. Whereas with us, from the very beginning, we've tried to be proactive in design and development and innovation. So we have a group that it's our internal Skunkworks. We call it Extra Super Hyper, which is an audacious name, and it's meant to be because we want them doing audacious things. And so we're pushing boundaries in physics and doing things and looking at new technologies all the time. And with AI and all the stuff that we have going on right now, it's changing rapidly. And so for us, it's a proactive stance. And honestly, I've been in aerospace for 20 years, and I've never seen another company outside of Lockheed Martin or Boeing that has that kind of a setup, which is interesting because Skunkworks and PhantomWorks and entities like that have done so well.
Yeah. And for the everyday citizen, well, let me go back a little. You'll appreciate this. Was it 66 years from Kitty Hawk to a person landing on the moon, right? That's insane. And very impressive. And, the Apollo 11 spacecraft, the Saturn rocket, 450,000 people worked on it for 8 years. So many moving parts. I think it's still the biggest and most powerful machine ever created. And ultimately, 2 people landed on the moon, and 3 people went into space. If you were to look back that 66 years, you probably wouldn't even believe it, right? But if you were to look back on the last 20 or 30 years, you'd be like, oh, yeah, I believe that innovation. But it is slower or even stagnant compared to like the glory days. What is your thought and position on that? Like, needs to move quicker?
It does need to move quicker. The aerospace industry moves too slow. So when you read things like China and Russia are passing us up on hypersonics, look, our military budget is way bigger than theirs. It's way bigger than anybody else's. It's massive. It doesn't shrink. And so when you hear politicians saying things like we should shrink the spend in the military industrial complex, what they're saying is let's shrink the growth of the spend in the military industrial complex. They're not talking about shrinking the budget. So even those that have been more progressive, like the Obama administration, everybody freaked out. But what he was talking about was reducing the growth from 5% to 3.5%, and people were freaking out. So it's really not going backwards. There's really no reason why those countries should be passing us. And so it becomes really interesting when you look at our history to say we have not done much from the 80s until now. We've done some things, like JSF is a really cool platform, but I worked on JSF. It took 15 years to design that thing. 15 freaking years. Like, why does it take 15 years to design anything? This is just all the bureaucracy and everything we built into our system, and so we do have to change it. We do have a voice, Intergalactic and Ram. We've been pushing this, especially on the intergalactic side, but it is a change that needs to happen if we're going to maintain our prominence and ability to defend the skies and space the way we want to.
And I think those are called moonshot
Yeah.
companies. Are you guys a moonshot company?
Absolutely. Absolutely.
So That's broad and ambitious, right? If you were to say, I'm CEO of Intergalactic, and we're kind of a moonshot space and aerospace company, they'd say, oh, cool, you're in Tacoma or Los Angeles, but you're in St. George. Let's talk a little bit about that.
Yeah, so we do not look at it as a weakness. We've leaned into it heavy. Obviously, when we did the acquisition, timing-wise, historically, that lines up with the remote work, trend that's happened, and we've always been remote work. We're actually remote work first right now, where most of our engineers are spread out across the country. But that's been really interesting for us to go through that process. But sorry, go back to your question again. What was your question again?
St. George.
Oh,
right?
St. George. I apologize.
How are you able to build that?
I apologize. So
No
yeah,
worries.
there's a lot there. It's loaded for me because when we decided to move it to St. George, our board did actively consider markets like Seattle, Dallas, and Los Angeles. Those are traditional aerospace economic centers. But the reason why I really wanted to lean into this is, one, remote work was becoming viable. For mechanical engineers, it was becoming viable, which everybody always said wasn't, because you're dealing with physical product. You're not dealing with code, so you actually have to touch it. The way you design something, the way it actually cuts out or actually is produced might be different than the design. So you're talking about tolerances that are a third the size of a human hair. Like, it's just different. But we leaned into it. So we said, yeah, no, it is possible, and we've really liked that. We've done it in St. George because St. George has so much to offer. It's a traditional retirement community, but for people who love the outdoors or just want higher quality of life, we saw a huge boom in transplants coming in during COVID because they wanted to get out of those economic centers. And it's the highest, it's been the fastest growing metropolitan area for 2 straight years now. So it is a fun environment, but it is intentional. It is another way to diversify and to differentiate ourselves.
Yeah. And whether it's 5, 10, 50 years from now, you will be able to confidently say you can build an aerospace and defense company in St. George.
Yeah, I mean, there's no reason why we can't. The world is flat. We have FedEx, we have UPS, we have the internet. You should be able to do this anywhere. Because we do work in the military, we can't do this outside of the United States, but St. George is an ideal location for us, and it's a lot cheaper than building somewhere in Los Angeles or something like that.
Yeah. You've mentioned a few things. You've mentioned the big service providers for the Department of Defense, Boeing, Northrop, Lockheed. You've mentioned military-industrial complex. And you don't need to be an expert in any of this to know there's like bureaucratic red tape and lots of procedures with the end goal of like having a really amazing fighting machine or a really amazing spacecraft, but also safety, right? Mm-hmm. So you guys are a cog in that wheel. From a business model perspective, and maybe you can juxtapose it for like a SaaS business or whatever you prefer, there's challenges in that. So how do you guys navigate that from all the way Uncle Sam saying, we need a spaceship that can do this, this, and this? Trickles down, right?
It's very hard because these platforms, again, are billions of dollars. They do have a political component, and they extend past administrations. And so you might have one president or one congressional administration that says, hey, we're going to buy off on this, and then the next one comes in and says, no, we need to cut that, which is really difficult to do. Again, physical products, especially when you're bringing a new technology and you're using advanced computing and all these different things, it can take us 3 to 4 years just to design it. And then by the time you're producing it and rolling it out, it's difficult. So that's really the hard part, is like that gestation period of like getting it to market, getting the product out there and starting to ship. The benefit, I guess, once you do that is there's no competition, because it is a monopolistic type of industry where you own that real estate. So if I'm on the Boeing 737, they can't buy that component from anyone else because I own that design. The only way they could do that is to start from scratch with somebody else who's a competitor and go through that whole design phase again, which is, again, 3 or 4 years, millions of dollars. They don't usually want to do that. So the benefit there is I can really, I don't want to say I can suck, but I don't have to. I don't need to perform at a top-notch level to keep my position, even though we want to. So there is a benefit there. Whereas like in a SaaS business, you're gonna have a lot more competition. There's gonna be more products coming to market, better products coming to market faster. So it's a bit different for sure. But that's really the long game for us, is to get on platforms. If you get on a platform like JSF right now has runway through 2091.
2091.
I'll be dead, probably. We'll be probably dead by then.
And JSF is Joint Strike Fighter, which is the F-35?
Yeah.
That's a long ways away.
It's a long ways away.
And it might look the same on the outside in 15, 20 years, but the inside will look a little bit different, and it'll probably need more thermal management, is my guess.
Yeah, it's a flying computer. So, Top Gun fans out there, we don't dogfight anymore. The last dogfighting aircraft we produced was the F-22. It's still our best dogfighting aircraft. That went into production, I think, in '95, and they don't produce it anymore. So JSF is not meant to be a dogfighting aircraft. It's a supercomputer that's meant to fight from a distance. It's got the best stealth and computing technology out there, and they do want to improve it. But the problem is, again, the heat factor. They can't improve it inside that envelope. So it's an interesting time.
Yeah, for sure. You're big on 80s pop culture.
Yeah,
right?
I am.
Flight of the Navigator. The premise is an
Thank
alien.
you. Thank you for bringing that up.
An alien comes and abducts a kid from Florida. I think he was right by the Kennedy Space Center. And then he comes back and can't remember anything, but he's on this awesome spaceship that was like a silver polymer, but it could morph into an arrow, or it could cruise along more like a blimp. If I was smarter and paid better attention in school, I'd love to work for Intergalactic, right? But I would add no value. But the curious part of me is somebody had that thought, right? They put it in a movie. But for folks like you, your engineers, you guys on your team, you would probably look at that as, let's get to that level, right?
Absolutely. I think it's a huge motivation for us. In fact, if anybody's ever down in St. George and you want to tour Intergalactic, I maybe shouldn't say this. I might have some people get mad at me, but I love showing it to people because that is the inspiration. I mean, there is a huge 80s element to our culture and to our brand. When you walk in, you feel it, you see it, but you think about the 80s, right? Whether it be the DeLorean, Fly the Navigator, Ghostbusters, all this next generation technology that they just sort of threw out there that was these guys working in their garage that just produced it, right? It's inspiring when you're a kid and when you see that and you're like, can you really turn a DeLorean into a time machine? Probably not, but we don't know everything and we're figuring things out, and space is allowing us to figure some things out pretty fast because the space environment is something we've never really worked in. And so there's so much opportunity for that stuff. Physics. I mean, I love that NASA now. I've met and had dinner with several NASA astronauts, several that have been on the space station. Even Charles Duke, who drove the lunar rover on the moon. And when you talk to them, they are convinced there's aliens. There's no way there's not, because they're just statistically, mathematically, it makes no sense. And when you're up there in the space station, you look out at space and you can see all the stars that we can't see. Because even it doesn't matter where you're at on Earth. You can be on the highest peak on the mountain with no lights around. You still can't see what they can see when they're up there. They're it is just overwhelming. It's just this feeling of there's no way we're alone. It's even stupid to think about that we're alone. So I think that stuff's really inspiring, but that 80s kind of pop culture really does a good job of getting you to think wow, could we do that one day? And we want to bring some of that back to this industry. Yeah,
I love it. Whether Flight of the Navigator, Back to the Future, Strange Brew, can you control people with a piano? It seems that got lost in the decades that followed. So it was a fun time to watch. But you can tell people at that time that were making those movies, that's what they were thinking about.
Yeah, I mean, Star Wars, I love it now because everybody's a critic when it comes to Disney Star Wars. But don't critically analyze Star Wars because none of it is factually based in science. The whole thing is completely not realistic, but it's fun and it gets kids to want to be astronauts. So why not lean into that?
Yeah. You do get this question, right, by kids watching a space shuttle launch, whether it's SpaceX or NASA, of why is that so big? Why is there so much fire coming out? And why does it not look like Guardians of the Galaxy or Star Wars or something, right, where you launch your spacecraft and then you fly into space? Eventually that will happen, right, unless we all just become stupid.
Yeah.
But that's 20 years of studying and figuring out all of that, right? It's a really hostile environment when you start going fast.
People don't understand. There's a famous equation called not the tragedy. It's something of the rocket equation. I'm just slipping my mind right now, probably because I'm on stage in front of all you fine people. But basically, in essence, we had to figure out that it has nothing to do with just launching something and punching it out of the atmosphere. You have to hit the right angle, mass comes into play, the mass to fuel, the overall mass of the structure versus the fuel, how you do that, it's different for every rocket and every size. And so we used to blow them up a lot. And now we figured out how to do that and how to automate it, but we still use, solid rocket fuel. We still use different, like an oxidizer and a fuel, like methane and oxygen, which we freeze to do it. And it's just a tremendous amount of fuel, and it does create almost like this massive explosion to be able to even do that.
Yeah.
So,
going back a little bit of how you guys produce your products and get them into the platforms or systems, are there any one-off, custom, we only need one of these? Does that make sense from a business model for you? Or what's the difference between custom and tell us what you need, we'll build it, or we will give you better ideas and build it custom, and then you can see how well it works?
Yeah, one thing most people don't understand is almost everything in aerospace is, and when I say aerospace, I'm saying aviation and space, is custom. That doesn't seem like it's a viable business model, but especially with stuff that's that expensive, but really they're trying to optimize for performance. And so when you customize, you can get maybe 1/4 of a pound out of something that weighs a pound, right? And they want them, and that adds up. In aggregate, that's a tremendous amount of weight you don't have to punch into the sky. So it's really important to be able to look at that and say, okay, that's the reason we're doing that. But sorry, what was the question again?
Yeah, the business sense of customization,
yeah,
and figuring out, all right, does this equate?
Yeah, so everything is customized, and so you have this customization element that's there. But every once in a while, we will get a request for a specific part or something that is a one-off, and it sometimes it makes sense. It depends on if it's a beachhead opportunity. If you can get into a market or with a customer that you've never done business with, maybe. I've done a lot of space jobs where it's just one-off because that's the way the space market used to be, where it was hey, we're doing a satellite and it's going to be one time. It's $1 billion satellite. But if you're on that satellite, then you get pedigree on a certain kind of part that you can then push strategically on other products. So stuff like that might make sense. It just depends on what it is.
Yeah. We're going to open up for questions in a minute, so get your courage up. This is a big learning curve, right? You had your experience with man, right?
Ram, yeah.
But it seems like this would be a bigger learning curve.
Yeah, it's a much bigger learning curve.
And correct me if I'm wrong, I don't think you do have a background in physics and science, or am I wrong?
No, I started out actually in mechanical engineering. I actually wanted to be a mechanical engineer the whole time I was a kid. When I went to college, I think my second or third year I switched over to business because I just felt like it fit me better. But I do have a technical background. I do understand engineering. So, but yeah.
So you obviously have a lot of smart people on your team.
Yeah, a lot that are smarter than me, for sure.
And very, the engineering, the mechanical engineering, the physicists, all of that. As the CEO, right, I guess, the buck stops with you with everything, but how do you manage that group of people? Mm-hmm. And then you've got the business side, right, and the marketing side. Again, it's a little bit unique, right?
Yeah.
How do you cope and deal with that?
I'm just who I am. I'm not pretentious. I don't try to be something I'm not. I really believe, there's lots of business tropes out there about getting the right person on the bus and stuff like that, but it's absolutely true. In my experience, especially in this world, I've worked with a lot of generals, I've worked with astronauts, I've worked with all sorts of people that are phenomenal leaders, and not one of them is good enough to run a company in every aspect. Some of them think they are. But when you realize what your strengths and weaknesses are, and then you start saying, okay, how do I get the best people to offset my weaknesses? And then you start building that team, and you form those relationships, and they trust you, and they know what you're bringing to the table, and you know what they're bringing to the table. It just creates this environment that's phenomenal. So I have Brad right here, who's our chief growth officer, who has, I'm sure he doesn't mind me pointing this out, he comes from Silicon Valley. How atypical is it in aerospace to have a chief growth officer, period, and then to have somebody from Silicon Valley? We get questions all the time on that kind of a thing, but again, it allows us to take some of those things from other industries that they do really well and apply them to an industry that really hasn't changed much in 50 years. And it gives us a chance to just do some simple things like social marketing and just really stick out. But Brad is excellent at what he does. If I got in the way and said, I can do everything he does and I need to be the smartest one in the room, Brad wouldn't have come to work for me and we'd be all worse off for it. So I think just being able to like have that self-awareness and say, this is where I'm weak and this is where I need help and this is the type of person I need, and then going out and finding that person, that's, it works.
Yeah. Yeah, maybe in 10, 15 years you could write a book, because there's a lot of CEOs, but there's not a lot of CEOs like in your industry, right? And I think the insights you would have, they can be applied to anything entrepreneurial, but it does have a lot of challenges. You've mentioned, the thermal management, all of that. Even, an eighth grader would know there's certain metals that are better or worse. You guys probably aren't going to the scrapyard and recycling steel, right? Tungsten, titanium, nickel, all of that. This is important for the ultimate supply chain, right? Is this, like if you guys had a chart of like, these are the things that could sink us, would any of those rare metals or key metals to your supply chain, would that be one of them?
So if you look at the metal situation, just to give some background, because we do military products, we have to buy US-based materials. And so that's not always true for commercial products, but generally speaking, we have to buy US alloys, produced alloys, which means that when you have situations where there's supply chain crunches, it really hurts us because the people who are buying in China start buying US, and then all of a sudden our market's gone, our supply chain's gone. And so it becomes difficult, but we do use a lot of metals like Inconels and Monels. These are super alloys that allow us to transfer heat at a higher level, especially in space. And so we don't go to the scrapyard. I mean, we use a lot of like 316 stainless steel, but it's, it's DO rated, or it's come through the military supply chain. But we are very particular on what we can use and why. So it becomes very important for us to understand what's going on there, for sure.
Yeah. The whole life cycle of this, right? Like this was in the ground somewhere, now it's in space 10 years later, and you guys are a part of that. Whether you're the new kid at school or the new person at work, like you're looking for acceptance, right? And you guys have big gorillas in your industry, and then a bunch of like smaller gorillas. It's a lot. Acceptance in this industry, how does that go and how does that work? When do you know if you're like, oh, like, I'm not at the table yet, or they're letting me in?
I mean, I think there's a few ways. We have a rating scale for technology development. It's the TRL scale. I think it was developed by NASA, but it's TRL 1 through 9, and 9 means you're fielding product and it's actually flying, and it's you've got production product out there. And that journey of getting past TRL 6 is really difficult because you do have to have a flight partner, essentially somebody who says your technology is good enough that if it works, it's worth the risk of putting you on. Because again, if these things fail, it can be billions of dollars. So it's a lot of money, but we have to follow that process, and it is difficult for sure. I mean, I think anytime there's a new company, the other groups, the big, the Lockheeds and Northrops of the world sort of like look at you through squinted eyes and say, okay, what are you going to do? But at the same time, that's part of their problem. They haven't leaned into new companies. They've tried to maintain what's been really an inefficient oligopoly type situation where they're controlling the whole market. And that's not a knock on them, it's just the situation. Instead of promoting growth and promoting competition and saying we need more, like let's do more. And I think that's starting to change for sure. So for us, for example, sometimes we do get met with a little bit of like tongue in cheek, and then other times it's like, you guys are it, this is exactly what we need, and it's interesting to see which companies take which path, if that makes sense.
Yeah, for sure. And how do those negotiations go? Are you leading those out? Do you have folks on your team that lead those out? Are they quick? Are they long? Are they painful? Are they easy?
They're long and painful generally. So Brad's team usually is leading those out, and it can be quicker. I mean, it depends on their situation. If they're in desperate need of a supplier and they don't have anybody and they can't find this product anywhere, then maybe it goes a little bit quicker. But the reality is we're usually designing from the ground up, and that process takes a long time. Our lead time right now to produce, even if we get the design done, to produce hardware is probably 80 weeks. So it does take a long time to do it. And quoting and winning work, I mean, I think we've got roughly 85 jobs right now that are just sort of sitting in our queue. And a lot of those have been sitting there for a year because it is tied to big budgets, and they haven't gone away. They're still on on deck. We're preparing for them, and we could win them. We just don't know when or how. So that part is hard to navigate for sure.
Yeah. So if I'm reading that right, you'd then need to hire those 85 people once you've got it.
Yeah, and that's kind of the way it goes. So you want to be strategic and get ahead of that curve too, because they are very technical positions a lot of the time. And so if you can bring them in earlier, doesn't matter what their experience is, then they can get in with what you're doing and start working on it and know what they're doing by the time you actually do it. But then what if that program slips out 6 months or a year? You've just brought a whole team on and that actually happened to us in 2020, and it really sucked. So.
Yeah. See, one more wrinkle that you have to deal with.
Yeah, it's difficult.
All right, we've got a microphone in the back. Raise your hand if you'd like to ask Brian a question.
So earlier you mentioned how AI is revolutionizing the workplace. Do you see it helping smaller companies or I don't know if Intergalactic counts as a smaller company, but smaller companies supplanting those more dominant companies like Boeing and Lockheed Martin? And then second question, if you could build any 80s style rocket ship or air platform, what would it be?
Yeah, so I'll answer that second one first because it's more fun. Probably an X-Wing would be really cool. If we had an X-Wing eVTOL that I could drive to work, that'd be really cool. The first question's more difficult because the Lockheeds and Northrops and Boeings of the world, they're actually airframers, and so they're building massive platforms. To be able to just produce an airplane for a startup would probably cost them $1 billion. And then to be able to scale that would cost several billion more. So even though AI could help to bring in competition, and it will, other companies will get up to that level. And there's other companies out there that are not quite as big as them, but could get there. It's just difficult to see that happening. Where I do think it can help the entire industry. So AI is going to help us to change as far as the way we design. So being able to consider things up front, in the olden days, it's sort of just whatever knowledge the engineer has or whatever resources they have available to them, and they design something, then they build it, find out it doesn't work because of XYZ reasons, start from scratch again, go back to the drawing board. That process takes years. And that's part of the reason aerospace takes so long to bring a new plane or something to market. But with AI and with advanced computing, you could statistically eliminate some of those design factors early on and go down a path that's more reasonable and more successful. So I think it's exciting. I think it could allow very small companies that really don't have a footprint, instead of taking a 25-year journey to be significant, and within 3 to 5 years they could jump some steps, which is really cool.
I really appreciate this information that you're sharing with us. It sounds like you've been very successful. I apologize about coming in late, and you may have already answered this. Why St. George? Were you already living there, and is it difficult to find to recruit individuals to move there, or are they given the option to work remotely?
It's a good question. Just in the news today on my feed, I had Tim Cook and Elon Musk again sorry, somebody's calling me. We're both in the news again saying, come back to the office. And it's this panic, something must be going on, even though all the data suggests we're more efficient. But for us in St. George, really what we decided, when we decided to locate our headquarters there, we also decided to perpetuate and support this remote work model that we've leaned into. And so most of our engineering leadership is across the country, and the reason for that is these are individuals who have worked for these aerospace primes, so like a Lockheed Martin or Northrop Grumman or whoever, and they've had a lot of success. And because of their success and their resume, they can choose to work for anyone, and any one of those companies will hire them. And if they want to get into a bidding war over their salary, they can. And so how does Intergalactic then throw its name in the hat and get them to choose Intergalactic? Well, we offer remote work, we offer flexible benefits, and we're a cool company. And so we lean on our brand, and we do those things, and we say, do you want to do, why do you get into engineering in the first place? Well, because, a lot of times I grew up in the 80s and I saw these cool platforms and I wanted to do that. Well, get back to that. Do you feel like you're doing that at the company you're at? No. Do you want to do that? Yes. Okay, come work with us and we'll do that. So you do build a bit of a culture that supports that and that helps St. George. But I think it is a differentiating factor for us. We're in this place that has a higher quality of life than some of these areas. I mean, I've worked with SpaceX for years. When you walk through SpaceX, and I was just there last month, there's no one over 40. And what's the problem with that is when you've got 6,000 people who are under 40, none of them can live anywhere close to SpaceX because SpaceX is in the heart of LA. So none of them live anywhere so they all live 2 hours away from work. So factor that in. So a lot of them are staying late every single day. Some of them are actually sleeping close by because they don't want to go home. So now we're saying you can work 10 minutes away from work. There's no smog, there's no traffic for now. It's a great place to live. That's a powerful message. Or you can just work from your house in LA. We don't need you to be here to contribute because we manage based on accountability and KPIs and things like that. So it becomes a different kind of conversation. And even so where you can start saying like, you can build a company like this in St. George. In fact, there's some advantages to building a company like this in St. George. So I hope that answers the question.
You're not very far away from an airport either, Las Vegas.
Right.
Hi. I had a question in regards to the finite amount of resources we have. You talked about supply chain. And so what is your company doing to promote sustainability? And I understand, obviously, it's at the point where, like, you don't want to be using recycled material on rockets, but, like, what are you guys doing to promote sustainability and long-term growth versus just, unsustainable practices?
Yeah, no, good question. So I think this is on our mind quite a bit because I personally don't think companies that are unsustainable, regardless of what they provide, eventually those companies will be diluted out of the market. It's just there's too much at stake right now, and so we very much care about that. But I think that the future for us and the future for aerospace is in material science. So the ability to break things down to their elements and work like in a nanospace, or to work on a molecular space where you're trying to take different elements and put them together. Sure, there are like rare earth elements and materials, but getting really good at efficiently using those in 3D printing and modeling, I think that is more sustainable than machining and milling, which is traditional for this industry. And so we very much lean into our vice president of engineering, for example, came to us from NASA and Lockheed Martin, had led several space missions. In fact, was chosen by NASA to run the next Mars mission, and he chose Intergalactic over NASA. And he is a material scientist, and that's one of the reasons we wanted him. But that was his whole thing is, you guys are approaching this the right way. Material science is the future. That's my passion. I would rather do that than work at NASA. So that's one way we're doing it, but we're always looking, for ways, can we become more green? Obviously waste, throwing stuff away for no reason. Can we repurpose these systems for other aircraft? No one likes to do that, but there's some opportunity to do that.
We've got a question on the live stream on LinkedIn from Kip Meekum. He asks, what are the other generalist subsystems that are ripe for being re-engineered the way you've addressed thermal management subsystems?
I mean, the way that I think all the systems could be re-engineered. I think that the problem is you really have a situation where this is the way, we went to a zero risk mentality as an industry. And this happened again post-World War II. If you read about World War II, I think we had just as many B-19s fall into the ocean as we did have them shot down. I mean, they were falling out of the sky like crazy. I think a quarter of them fell out of the sky, something like that. So that's really sketchy if you're trying to then take airplanes and say, hey, American citizens, you should be flying. You should be doing business travel. And so the way that they got around that was they just mitigated risk to the nth degree. No new systems, figure out what's wrong with it, get really analytical about, this root cause analysis and figure out what the problem is, and they just make those systems really good and reliable, and they have. It's sort of like Honda, right? You go back like 40 years, no one wanted a Honda. Now they're like one of the most reliable cars on the road, or Toyota. That's the way that they've approached this market. The problem with that is that they've had ample opportunity to push new technologies that would have done more for us, like we really should be able to fly from Los Angeles to London in 4 hours. It shouldn't take 12 or 14 hours. There's no reason it should, but it's, again, attacking those systems, redesigning them, looking at them and saying, well, how can we do this? And cost does factor in. And so really everything out there can be. Thermal management has a bigger opportunity because thermal is the biggest issue in aerospace right now. But certainly the way every system plays in, there's a lot of this. We see it everywhere in every type of systems and structures within the industry.
You've touched a bit on how you have brought in this amazing engineering talent from these legacy aerospace companies, but I feel like your culture of Intergalactic maybe differs from the legacy culture of a lot of those, where it's much quicker innovating. Has it been a struggle at all to get engineers to adapt to that culture, or are they usually eager to accept it? And for people in the legacy aerospace industry, do you have any suggestions on how they can change their mindset a little bit?
Yeah, for sure. It is a struggle. It was a struggle. It's been a struggle for me because, you're brought up a certain way and you're taught certain things, and those things are law in these different companies you work in. And then you get out of that environment and you realize that's not really something I have to abide by. It's just something they did, but there's other ways to do it, and it's pretty cool. But you get stuck in these situations where you'll be like, why are we experiencing that problem? And it's because somebody's doing something they learned at a big aerospace company. It does happen kind of often. And so you have to change the way people think. And that's why, having people like Brad within the organization that come from Silicon Valley that have seen high growth environments is so important, because he can say, look, you're feeling anxiety because no one in this industry does this. It's your subconscious saying, hey, danger, danger, danger. That's not the way you're supposed to do this. But I'm here to give you comfort. You can do it that way. We'll be okay. And that's been good. But I think just, there is a lot of like this culture where if you go visit these big aerospace companies, you walk into like these cubicle farms with like, we always joke around like stained cubicles and blinking lights. And it's like, oh yeah, if I'm a top end engineer, that's where I want to work. It's super creative. So just even upgrading those things and taking care of your people, making an environment where high-end technological, where those people want to work, or technical people want to work, that's something they could really do. Because I know a lot of aerospace engineers feel like commodities. They feel like they're just hired to work on a certain platform, and the company's just going to let them go as soon as they're done with that thing. At Intergalactic, we don't do that. We focus on their experience and them as people, and it works out for us.
Last question, and for those that didn't get to ask Brian, he'll stay here. Go ahead.
One more from the live stream from Alessandro Cosi. He asks, you have spoken about culture and working remotely. Is it hard to preserve culture when people working across the whole U.S. and throughout the world?
Yes and no. I mean, it sometimes feels like we're all in the same place because we're on teams all day, every day. So we have these like phenomenal cultural artifacts, like, these teams chat, like, you get these channels going where it's like, it's just fun, and everybody's interacting with each other and having a good time. But, when we do any kind of meeting and we have people that are off site, we ask them to turn their cameras on. We want to see their faces. So I think the technology, when you use it correctly, kind of mitigates that a little bit. I don't think it's as important as people think it is.
Last question is favorite 80s movie?
Ghostbusters.
Ghostbusters.
Yeah.
Thank you so much, Brian. This one could have gone for hours and hours, but if the offer stands, next time I'm in St. George, I want to see.
Absolutely, for sure. We love showing it off. It's a lot of fun.
Very cool. Thank you for joining us, and congrats to you and your team on what you're doing. It's very awesome. Thank you.
Thank you.